Bismillahirrahmanirrahim. Today we are going to solve some numerical problems from chapter number 5, class 9th, gravitation. Question number 1 is, find the gravitational force of attraction between two spheres, each of mass 1000 kg. The distance between the centers of the spheres is 0.5 meter. Let's solve this. Given m1 is equal to m2 is equal to 1000 kilogram. Distance between the centers d is equal to 0.5 meter. We know g is equal to 6.673 into 10 to the power minus 11 Newton meter square per kilogram square. And we have to find the force F. We know that F, the force of attraction between two spheres, is equal to m1 m2 over d square into capital G. Now putting the values, F is equal to 6.673 into 10 raised to the power minus 11 into 1000 into 1000 over 0.5 square. Now we calculate this. This is equal to 0.5 square zero 0.25 6.673 into 10 raised to the power minus 11 into 10 to the power 6. Now let's calculate this. 6.673 divided by 0.25 is equal to 26.692 into 10 to the raised power minus 5. And we can write it as F is equal to 2.67 into 10 raised to the power minus 4 Newton. This is the required answer, which is asked to find the force of attraction between the two identical spheres of mass 1000 kg each. Thank you for watching. Please subscribe my channel, like my videos, share my videos. If you have any question in your mind, please write in the comment box. Thank you. Bismillahirrahmanirrahim. Today we are going to solve Physics Numerical 5.2. The gravitational force between two identical spheres kept at 1 meter apart is 0.006673 Newton. Find their masses. Let's solve this. Given m1 is equal to m2 is equal to m and distance between their centers is equal to 1 meter, and force of attraction between them is equal to 0.006673 Newton. We know G is equal to 6.673 into 10 raised power minus 11 Newton meter square per kilogram square, and we have to find mass m of each sphere. We know that F is equal to G m1 m2 over d square, which is equal to G m square over d square. As it is given, m1 and m2 are equal, so m1 into m2 is equal to m into m is equal to m square. Now m square is equal to F over G into d square. F is equal to 6.673 into 10 raised power minus 3 over G 6.673 into 10 raised power minus 11 d square is equal to 1 square. These terms cancel each other. We got 1 into 10 raised power minus 3 plus 11 into 1. 1 into 10 raised power 8. M square under root is equal to 10 to the power 4 square, and under root m is equal to 10 to the power 4 kilogram. So m is equal to 10,000 kilogram each. So each spheres, where the mass of each sphere is 1000 kilogram. Please subscribe my channel, like my videos, share my videos. If you have any question in your mind, please write in the comment box. Thank you. Rahim. Today we are going to solve question number 5.3 from physics 9th class. Find the acceleration due to gravity on the surface of Mars. The mass of Mars is 6.42 into 10 to the raised power 23 kilogram, and its radius is 3370 kilometer. Let's solve this. Given mass of Mars is equal to 6.4 into 10 raised power 23 kilogram. Radius r of Mars 3370 kilometer, which is equal to 3.370 into 10 raised power 6 meter. We know G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kilogram square, and we have to find the value of G at Mars. We know G at Mars is equal to G mass of Mars over square of the radius of Mars. We know that G at Mars is equal to G m mass of Mars over square of the radius of Mars. Putting the values, we got 6.67 into 10 raised to power minus 11 into 6.4 into 10 raised to power 23 over 3.370 into 3.370 into 10 raised to power 6 to the power 2. On simplification with the use of calculator, we got 3.77 meter per second. So gravitational acceleration at Mars is equal to 3.77 meter per second is the required answer. Please subscribe my channel, like my videos, share my videos with friends. If you have any particular question in your mind, please write in the comment box. Thank you. Rahim. Today we are going to solve question number 5.4. The acceleration due to gravity on surface of moon is 1.62 meter per second. Find the mass of the moon. Radius of moon is 1740 kilometer. Let's solve this. Given G at moon is equal to 1.62 meter per second. Radius of moon 1740 kilometer or 1.740 into 10 raised power 6 meter. We know G is equal to 6.673 into 10 raised power minus 11 Newton meter square per kilogram square. We have to find the mass of moon is required. We know that G at moon is equal to G into mass of moon over square of the radius of the moon. Now mass of moon is equal to G at moon over capital G into radius of moon square. Now putting the values 1.6 into 1.740 40 into 10 raised power 6 square over 6.673 into 10 raised power minus 11. We got on simplification 7.35 into 10 raised power 22 kilogram. I simplify this with the use of calculator. Please subscribe my channel, like my videos, share my videos with friends. If you have any particular question, please write in the comment box. Thank you. Bismillahirrahmanirrahim. Today we are going to solve numerical problem 5.10 from the chapter The Force of Gravitation. A communication satellite is launched at 42,000 km above Earth. Find its orbital speed. This is a similar question as we solved in 5.9. Let's solve this. Here given is height h is equal to 42,000 kilometer. We know r, the radius of the earth, is equal to 6,400 kilometer. R plus h is equal to 48,400 kilometer, which is equal to 4.84 into 10 to the raised power 7 meter. We also know that the value of G is equal to 6.673 into 10 raised power minus 11 Newton meter square per kilogram square. These are the values we know, and we also know that mass of the earth is equal to 6.0 into 10 raised power 24 kilogram. We have to find GH, the gravitational acceleration at height h, and then we find the orbitals. We have to find gravitational acceleration g at height h, and then we find orbital velocity v naught or v orbital. We know that GH is equal to G ME over R plus H square. Now putting the values, 6.673 into 10 raised power minus 11 into 6 into 10 raised power 24 over 4.84 into 10 raised power 7 whole square, which is equal to 6.63 into 6 into 10 raised power 24 minus 11 over 4.84 square into 10 to the raised power 7 into 2. Now we calculate it. 6.673 into 6 for 0.038 into 10 to the raised power 13 divided by 4.84 square (23.4256) into 10 to the raised power 14, which is equal to 0.038 divided by 23.4256, 1.7091 over 10, or GH is equal to 0.1709 meter per second. We know V orbital is equal to under root of GH into R plus H, which is equal to under root of 0.171 into 4.84 into 10 to the power 7. And now we simplify it. 0.171 into 4.84, this is equal to 8.276 into 10 raised power 3 square under root, which is equal to 8.276 under root of 8.276 2.8768 into 10 raised power 3 meter per second, which is equal to 287.6.8 meter per second. Please like my videos, share my videos with friends, subscribe my channel. If you have any particular, we are going to solve numerical problem 5.5 from 9th class. Calculate the value of G at a height of 3600 km above the surface of the earth. Height h is equal to 3600 km, or radius of earth is equal to 6400 km, or plus h is equal to 10,000 kilometer. or 10 1.0 into 10 raised power 4 into 10 raised power 3 meter, which is equal to 1 into 10 raised power 7 meter. We know G is equal to 6.673 into 10 raised power minus 11 Newton meter square per kilogram square, and mass of the earth is equal to 6.0 into 10 raised power 24 kilogram. We know G at height h is equal to G mass of earth over square of the radius of the earth plus height, r plus h square. Now putting the values, we get 6.673 into 10 raised power minus 11 into 6 into 10 raised power 24 over 1 into 10 raised power 7 square. On simplification, we got 0.02 over 10, which is equal to 4 meter per second per second. So G at given height h is equal to 4 meter per second is a required value of the gravitational acceleration at height 3600 kilometer above the surface of the earth. Please subscribe my channel, like my videos, share my videos with friends. If you have any particular question in your mind, please write in the comment box. Thank you. Rahim. Today we are going to solve numerical problem 5.7 from 9th class, chapter number 5, the force of gravitation. The value of G is 4.0 meter per second at a distance of 10,000 kilometer from the center of the earth. Find the mass of the earth. Given h is equal to 10,000 kilometer and r radius of earth is equal to 6,400 kilometer, r e plus h is equal to kilometer, which is equal to 1.64 into 10 raised power 4 into 10 raised power 3 meter, or this is further is equal to 1.64 into 10 raised power 7 meter. G is equal to 6.673 into 10 raised to minus 11 Newton meter square per kilogram square. Here required mass of Earth is required, we have to calculate the mass of the Earth. We know G at H is equal to 4.0 meter per second per second. We know GH is equal to G mass of the Earth over R plus H whole square, and mass of Earth is equal to GH into R plus H square divided by G. 4 into 1.64 into 10 raised power 4 square over 6.673 into 10 raised power minus 11. On simplification, we got 5.99 into 10 raised power 24 kilogram. So mass of Earth is equal to 6.0 into 10 raised power 24 kilogram. Thank you for watching. Please subscribe my channel, like my videos, share my videos. If you have any particular question, please write in the comment box. Thank you. Bismillahirrahmanirrahim. Today we are going to solve numerical number 5.6, 9th class, chapter number 5. Find the value of G due to the Earth at geostationary satellite. The radius of geostationary orbit is 48,700 km. Let's solve this. Given R plus H is equal to R naught, the radius of geostationary satellite, is equal to 48,700 kilometer, which is equal to 4.8700 into 10 power 4 into 10 power 3 meter, which is equal to 4.87 into 10 to the raised power 7 meter. We know mass of the Earth is equal to 6.0 into 10 raised power 24 kilogram. G, gravitational constant, is equal to 6.673 into 10 raised power minus 11 Newton meter square per kilogram square. We have to find the value of gravitational acceleration G at geostationary satellite. We know that G at geostationary satellite is equal to G mass of Earth over square of the geostationary satellite orbit radius. Now putting the values, 6.673 into 10 raised power minus 11 into 6 into 10 raised power 24 divided by 4.87 into 10 raised power 7 square, which is equal to 6.673 into 6 into 10 raised power 13 over 4.87 square into 10 to the power 7 square, which is equal to 0.038 over 23.7169 into 10 raised power minus 1, which is equal to 0.168, or we can write it as 0.17 meter per second per second. So G naught is equal to 0.17 meter per second is the required answer we have to calculate. Please subscribe my channel, like my videos, share my videos with friends. If you have any particular question in your mind, please write in the comment box. Thank you. Today we are going to solve a numerical problem from the chapter The Force of Gravitation. Numerical number 5.9. A polar satellite is launched at 850 km above the Earth. Find its orbital speed. Let's solve this. Its solution is given as first of all we write here given height h is equal to 850 km, radius r of the earth is equal to 6400 km, r plus h is equal to 0, 5, 2, 7 km, which is equal to 7.25 into 10 raised power 3 into 10 to the raised power 3 meter, or this is further is equal to 7.25 into 10 to the power 6 meter. We know G is equal to 6.673 into 10 to the raised power minus 11 Newton meter square per kilogram square. ME, mass of the earth, is equal to 6 into 0 into 10 raised power 24 kilogram. There is a minus. required. What we need to find? To find the speed of orbital speed, we need GE, the gravitational acceleration or acceleration due to gravity on height h. First of all, we find that, and then we find V naught, VO, orbital velocity. We know that GH is equal to G, mass of Earth, over R plus H whole square. On putting the values, we got GH is equal to 6.673 into 10 raised power minus 11 into 6.0 into 10 raised power 24 divided by 7.25 into 10 raised power 6 whole square, and this is equal to 6.67 into 6 into 10 raised power 24 minus 11 over 7.25 into 7.25 into 10 raised power 12. GH on simplification is equal to 7.617 meter per second per second. We know V orbital is equal to square root of GH into R plus H. V naught, V orbital is equal to 7.617 into 7.25 into 10 to the raised power 6. On simplification, we get 55.245 square root into 10 power 3 whole square root, which is equal to 7.433 into 10 raised power 3 meter per second, which is equal to 7433 meter per second. This is the required orbital speed we need to calculate. Thank you for watching. Please like my videos, share my videos, subscribe my channel. If you have any further question in your mind, please write in the comment box. Thank you. Bismillahirrahmanirrahim. Today we are going to discuss a numerical problem from the chapter The Force of Gravitation. Problem number 5.8. At what altitude the value of G would become 1/4 than on the surface of the earth? Let's solve this. Its solution is given as, we know that G is equal to G ME over R square. G is the constant of gravitation, me is equal to mass of the earth, while r is radius of the earth. We also know value of G at height h is equal to G me over r plus h square. It is given GH is equal to 1/4 of G, which is equal to G me over 4 into r square, which is further equal to G me over 2 r square. Now compare G me over r plus h square is equal to G me over 2 r square. This implies r plus h is equal to 2r and h is equal to 2r minus r, or h is equal to r. If height h is equal to the radius r above the surface of earth, then the value of G will be, GH will be 1/4 of G. Thank you for watching. Please like my videos, subscribe my channel, share my videos with friends. If you have any particular question in your mind, please write in the comment box. Thank you.